All right, example 4, the first washer example. Let's go ahead and sketch this region. We are to determine the volume of the solid generated by rotating this region, y equals x squared plus 4 and y equals 2, about the x-axis for x between 1 and 3. So first step, as always, is to sketch the region. So draw our axes, labels. We've got y equals x squared plus 4, so maybe I made my axis too short on that one end, but x squared plus 4 is going to look something like that. Opens upward, y-intercept of 4. Y equals 2, so that's going to be somewhere right in here. And then let's see here. So between them, for x between 1 and 3. So x equals 1, I'll say is there. Let's say 3 is right there. This, of course, I can make it a little bit more drawn to scale. So that's what we have. So x equals 1, I can draw the vertical line for it. Similarly, I can do the same for x equals 3. So there, we should now have all of our boundary pieces. So to highlight this in blue, we have x equals 1 as a region, the parabola, excuse me, I meant to say boundary, x equals 3 as a boundary, and y equals 2 as a boundary. So this region is to be rotated about the x-axis. So let's just draw a little rotation symbol there. Okay, so clearly there is this gap between the axis of rotation and our region. So once you identify your axis of rotation, which I'm in the habit of always kind of drawing this little symbol here, let's remind ourselves that since we are rotating about the x-axis, using our formula for washers, this will be the outer radius squared minus the inner radius squared, dx, since we're integrating about a horizontal axis. All right, so our main task now that we have our axis, our rotation axis identified, and we have determined that our integration should be with respect to x in this case, our next task is to figure out what the radii are. So the way you do this is you always measure the radius from the axis of rotation. So I would just start with drawing this little arrow from your axis of rotation. And notice this is going to be, since it's the first thing you hit, this is going to be the inner radius. And then if you keep going through until you hit the second thing, that second thing you hit constitutes the outer radius. So the inner radius is 2, and the outer radius is, well, it's the y value, and the y value along this curve is x squared plus 4. So x squared plus 4. Again, if we were rotating this region about the y-axis, we would have to change a few things, but for instance, we could have just left this written as y, because we would have been integrating with respect to y, since it's a vertical rotation. But for us, we're doing horizontal, so we did need to change that y over, and we do that by that relationship between x and y on this curve. Okay, so now that we have this, we have pi times the integral from start to finish, left to right. So this would be from x equals 1 to 3. Outer radius squared, so we'd have to expand that, minus the inner radius squared, so 4. Okay. For this one, again, the technique of integration is very straightforward. It's just power rule, so not worth going through all of those steps. So omitting those, we should have the answer be 21/26 pi over 15.